Greetings and welcome to this 3D Motive comprehensive course on creating a box-pushing puzzle game in the Unity engine. I'm Alan Thorne and I'll be your instructor as we explore how to build a 3D puzzle game every step of the way, from start to finish. Throughout this course we'll take an in-depth look at a wide range of Unity features, from level design and lighting configuration to inverse kinematics, character animation, and also load and save game functionality. In this fourth part of the course we'll add polish and finesse to our box pushing game. Specifically, we'll create an overarching game manager to play music and handle level switching, taking the gamer from one level to the next. Then I'll show you how to light dynamic objects such as the player and the crates using the Unity Light Probe system. And finally we'll add extra flair and glamour by creating a torch particle system, as well as adding image effects including bloom and vignette. There's plenty to see and do here, so without further ado, let's get started. So here we are in the Unity editor, and I have open in front of me here the first level that we have assembled, complete with the destination points and the crate objects. We have the player character, which has inverse kinematics configured. We have the destination points which can accept these crates, and the crates keep track internally through the crate class of whether or not they are standing on the destination points. So if I press play on the toolbar, for example, and I select a crate object, you can see here it has a crate component with an is on destination field. So when I move around here to push the box onto the destination, you can see here that this field is enabled. In fact, it's not right here because I don't have this crate selected, but one of the crates somewhere, in fact this third crate here, this has that field enabled because this is the crate we are referring to here. Now, of course, it's possible for all these crates to keep track of whether they are on the destination, but of course, once all these crates end up at their destination, we need to move to the next level, and we need to implement functionality to do that. Now, to achieve this, I'm going to be creating a Game Manager class, which is going to be a singleton object. It's going to be an object that sits there in the scene, completely invisible, and determines whether the crates are all on their destinations. So to get started with this class, I'm going to move down here to the project panel under the Assets Scripts folder. I'm going to right click and from the menu choose Create and C# script file, and I'm going to create a new script file which I will call Game Manager, like so. And of course I'm going to open up this file in MonoDevelop and then begin to edit it. But I will do that in the next video. So I'm here in MonoDevelop and I have open in front of me the Game Manager C# script file that we began in the previous video. And what I want to do now is to take a look at this code which I've added off screen and explain what it does and explain its purpose and why I have added it. You can see here that I've added a property here called instance, and I've added a private member variable here called instance, and also an awake function which performs some object destroying functionality and some instantiation. So I'm just going to minimize MonoDevelop here and explain first of all why the Game Manager class that we've created here differs from all of the other classes that we have so far. Consider, for example, the crate object that we have here. Now I can drag and drop this code onto each of these crates and create multiple instantiations of the class. We have one for each of the crates, and that's fine, that's how it's supposed to work. But in the case of the Game Manager, it's different. Instead, I want to create just a single game object, so I'm going to choose Game Object, Create Empty, and in the Object Inspector I'm going to give this a name of Game Manager, and I'll reset the object position back to the origin here, and drag and drop the Game Manager here onto the Game Manager object. So you can see now that I've added this component. This Game Manager is quite different from the other objects we've created because in this case we want just only one instantiation of the class. It is a managerial class. We need only one instance of the level and never any more than one. And so we can use C# script to intentionally code into our class some functionality to ensure that we can only ever have one instance of the class and that we can't instantiate more. Let's see how the code in MonoDevelop works to achieve that. So jumping back here to MonoDevelop to the Game Manager C# class, you'll notice the first thing that we have is this private static member variable called instance. And the static keyword here is important. It means that it's going to be a variable that is shared between all instances of the class if multiple instances are made. So this is a kind of shared variable between all instantiations, and that really is what static does. So here we have a property which is called instance, and what it does is it returns an instance, it returns a pointer or a reference to this variable here if it is valid, otherwise it instantiates a new game manager. So how does all of this kind of tie in and work together? Well, the key can be found here in the awake function. This function is called on the game manager object when it is created in the scene. So it's the very first function that is called for this class. So the first thing we do here is we say, okay, is there an instance of this class already in the scene? If there is an instance already in the scene, then we will destroy this instance because we know that we're not going to need any more than one instantiation. But of course, if there are no valid instances of this object in the scene, then we'll just assign the instance variable, this private member variable here, to the current instance. So how does this help us at all? Well, first of all, this code ensures that there's only one instance of the game manager available in the level. But it also means that absolutely any other class in our project, it doesn't matter which one, any other class, they can always have direct and immediate access to the game manager variable. So what does that mean? Well, let me show you. I'll just minimize MonoDevelop here and I'll double click, for example, the crate class. So just double click that, open that into MonoDevelop, and here we have the crate.c# class. Now if this class wanted to access the Game Manager C# class, well, we can do that quite easily. I'm just going to insert some lines here and I can simply say Game Manager dot instance, and there, by doing that, now I can just press the period symbol and access all of the functionality inside the Game Manager class, and I always know that this refers to the active instance of Game Manager. I don't need to, for example, add any public property up here to the Game Manager class and then pass in a reference to the class up here as a property. I can simply say Game Manager.instance, accessing that static variable, and always get access to the active Game Manager. That functionality is going to come in very handy later in this course, but right now we're making progress with the Game Manager. We've now made it a singleton object. It's time to move on and handle the level switching functionality. So now I want to implement the level switching functionality into the Game Manager singleton object that we began to create in the previous video. In this video you can see here I've got the first level open in front of me, and when we push all of these boxes onto their destinations, we want to display a level complete message and then move to the next level. Now off screen I've gone ahead and added that code, the necessary code, into the Game Manager, and we'll be examining that in just a moment. You can also view the full source code for that file in the course companion files. The first thing I want to do before getting ahead with any code at all is to assign our levels unique numbers so that Unity knows which level is which. You can see we have our two levels here, 0, 0 and 0, 1, and to give these numbers all I have to do is move up here to the File menu, choose File, and then select Build Settings, or I can press Ctrl-Shift-B on the keyboard. I'll bring up the Build Settings dialog, and all I have to do is drag and drop the first level into here, and you can see it's assigned the value of 0, and I can drag and drop the level 0, 1, and that's assigned the value of 1. So now our levels have unique numbers, and that will be important. I'm just going to close the Build Settings dialog, and if I switch over to the Game Manager object in the Hierarchy panel, you can see here in the Object Inspector that the Game Manager component now has some additional parameters which I've gone ahead and added. We'll see those in just a moment, but one of them is Next Level, which indicates the level that should be loaded next when this one is completed. So what we have in front of us here is level 0, 0, and when this level is completed we want to load level 0, 1. So I'm going to set the value for next level from 0 to 1 because that's the level that we want to load. I've also added this property here, level complete graphic. If I just expand the object inspector here, you can see that it's level complete graphic and it accepts a sprite value here. So I'm just going to retract that back into here. And it's asking for a sprite object that we're going to display on screen when the level is completed. I'm going to switch over to the textures tab and you can see we have the Atlas texture here. If I just expand that, you can see that we've got this sprite level complete icon, and I'm going to drag and drop that over here into the level complete graphic slot in the object inspector to just indicate that this is the graphic that I want to display on screen when the level is completed. Okay, so that's the basic configuration that we need to provide for the game manager script. Of course, all of these variables that we've added here, they are the result of code that I've gone ahead and added in the source file. So what I'm going to do now is just jump back over to MonoDevelop here to bring up the game manager C# script file and get started at examining this code and how it works to handle level switching. So now let's examine the level switching functionality coded into the game manager class. To detect when the level has been completed, all boxes need to be on their destination, so the game manager class needs access to all of the crates in the level. So if I just scroll down here, you can see that I've added this variable at line 62, which is an array of all the crates. So I've just created an array of crate objects. These are the crate class that we've coded before. So here we're just storing an array of crates. Now in the awake function, you can see here at line 80 that I call on GameObject find objects of type and I specify a value of crate to retrieve all of the crate objects in the scene, and these are stored in the crates array. Now that really just gets us access to all the crates in the level, but of course it doesn't check if they are on their destinations. To do that, I've coded a check for win function, which you can see here at line 84, and here we cycle through all the crates in the level and we check their value B is on destination, and we know that even if one of the crates has this value set to false, then the level can't possibly be completed because it means at least one of the crates is not on the destination. And so we can return a value of false, that is to say that the level has not been completed. Of course, if all of them are on the destinations, then we set the level complete property to true and we return a value of true. Now this check for win function, this is called once on every frame. We can see that if I scroll down even further to the update function, which is coded at line 122, you can see on line 131 that we call check for win, and that repeats every frame to see if the level condition, the level win condition, has been satisfied. So that's how we go ahead and we check for a level complete situation. But of course, when the level complete flag here that you can see level complete, when that is set to true, it's important to remember that this level complete property here, it's a property and not a variable. That means that if I scroll further up into our class here, you can see that we have a level complete flag, a property set here, which performs additional functionality whenever its value is set. In particular, what we do is we check to see if the level has been completed, then we start the coroutine move to next level. And what this coroutine will do is display the game win, the level completed texture on the screen, and then we'll move to the next level. So I'm going to be considering that functionality next. In the preceding movie, we examined the bulk of the level complete functionality for the game manager class, but I want to just take a further look now at the final part of the code for this functionality and then to test it into the level. So you can see I've got this start coroutine move to next level, which is initiated when the level complete flag is set to true. Let's scroll down and have a look at the function move to next level. If I scroll down, you can see the function is listed, here we are, move to next level. It's a coroutine because it has the IEnumerator return type. And you can see that what we do is we wait for an interval, which is win wait interval, and then we move to the next level by using the application.loadLevel function, which is part of the Unity API. This is a Unity function to change to the next level. So we wait for the win wait interval, and that is the amount of time in seconds that we have to wait while it displays the level complete graphic. And you can see here in the onGUI function that we call on the GUI class to draw the wing complete, the level complete texture onto the screen. We draw it at the center of the screen. So you can see that's the basic functionality for displaying the level complete graphic here. So I'm going to press Ctrl S on the keyboard to save the changes to the Game Manager class. Let's just minimize Mono Develop and return back here to the level editor. And I'm going to press the play button on the toolbar here to initiate playback. And I'm just going to push these boxes onto their destinations and really just display the level complete graphic and move to the next level. So let's just push this box into the corner here. And that's box number 1 pushed onto the destination. Let's just move the next box, this one here. Let's go over here and push this box onto the destination. It's just a straight run here. And then the final box, which should display the level complete graphic. Let's just move it here and around this side and push this onto the destination, and ta-da, level completed. And then we jump to the next level. Now right now I've not put the player or the destination points or the crates into this level. That's absolutely fine, we can do that at any other point, but you can see here that we've jumped from the first level to the next level. So things are looking good. It's time to move on. So in this part of the course I want to consider the issue of real-time illumination using light probes. We saw in volume 1 of this course how this environment in front of us here was illuminated using light mapping, and we could do that because these objects were static and they didn't move at runtime. But we have a different scenario with the crates and the player character. Both of these move around during gameplay, and so the illumination for them is quite different. Right now they're using dynamic, completely real-time illumination, and we can see that, for example, if I select, let's just select in fact all of the lights here and just move them completely out of the level, and as I move them away you see that everything that moves, everything non-static, immediately turns completely black because it's out of the range of any of the lights. In fact, if I rotate the view around here, you can see that this face of the box is away from most of the light sources here, and it's completely black. But that's not really how objects look in the real world, because they receive a certain amount of indirect illumination. That is bounce lighting, lighting that is bounced off of other objects and then bounced around here to illuminate this surface. Now of course some of this indirect illumination can be simulated using ambient light. We could in fact select edit and then choose render settings, and over here in the ambient light section I could just boost up the ambient light, and you can see that here we're getting the appearance of some indirect illumination, but what this does is it brightens all of these other surfaces as well, and that really is not what we want at all. So I'm going to completely disable the ambient light here. And to illuminate the player character as well as these boxes, I'm going to be using a feature in Unity known as light probes, and this allows us to kind of semi-bake the real-time lighting in the level so that we get some real-time effects, but much more optimally than using this dynamic lighting which we are using here. So in the next video I'm going to be showing you how to get started at using that. So to get started at using light probes for the dynamic objects in this level, I'm just going to fold up the groups that we have already here, and I'm going to create a new object in the scene. So I'm going to choose Game Object, Create Empty, and I'm going to name this object Light Probes, and I'm just going to reset its position back to 0, so just reset that there. And we have this object at the center of the level, at the origin. Now what I'm going to do next is I'm going to come up here to the component menu and choose component, and then I'm going to choose rendering, and then I'm going to choose light probe group to add a light probe group component to this object, and you can see that group here. Now the object, what we're going to do, the objective is we're going to be adding these kind of spheres or balls in the level that are going to be sampling the light at particular positions. So let's add the first probe. I'm just going to press this button here in the object inspector, which you can see is add probe. So I'm going to select add probe, and straight away if I press F on the keyboard to frame the object, you can see we get this sphere, and I'm just going to raise this up in the scene. So again, we can transform the sphere just like any regular object, and in fact even if I deselect it, I can just select it again just like a regular object and begin to transform it in the scene. Now this object is completely invisible at runtime. If we were to switch to the game tab and press play on the toolbar, you'd see that we can't see it in the level at all. So I'm just going to press stop here, switch back to the scene tab, and just return back here. You can see we've got our light probe. So what I want to do is I want to start to build up a network of these probes in the level. And the main aim here with these probes is to really put them at key points in the level, perhaps where the light changes, where there's great variation in the lighting, or where there are any key and critical areas where there's light in the level. So for example, I'm going to put one probe around about here. And what this will do eventually is sample the lighting in this area. And it will kind of create an average of that lighting and bake that down into the probe. And then at runtime it's going to interpolate the lighting on our objects across all of the probes. So I'm going to position one here. Now I can add a new probe just by choosing add probe again, or with this probe selected I can press Ctrl D on the keyboard to duplicate that probe and just bring in a new probe here. So I'm just going to put a probe in here, maybe raise it down a little bit and bring that over. Bring it over here just a little bit, like so. Again, press Ctrl D and just bring this probe outwards here. The idea, the main aim here is to have as few probes as possible. The fewer probes we have, the better it will be for performance. But I'm just going to put a probe in here, press Ctrl D to bring another probe over to this side, like so. And again, I'm going to press this one, press Ctrl D, and sort of bring over this probe here to this point in the level. Just maximize the viewport here, and it might be quite difficult to see, but if you look carefully you can see that these probes are connected together by these thin lines here, which connect the probes together and really define how the lighting interpolation is going to work. So I've put these probes in these key positions. Obviously the positions for your light probes will differ depending on how your levels are arranged, but I'm kind of happy with this sort of probe arrangement here. Now of course the next thing we need to do is to actually bake these probes. That is, we actually need to bake in the lighting in the level into each of these probes, and we can do that by using the light mapping panel. So I can press window and choose light mapping, or I can switch over to the light mapping tab here. I have that docked in the editor, and right here we've got this button here that says bake probes. If you don't see that button, then you can press on this drop down arrow and choose bake probes from the menu. So I'm going to select bake probes, and that goes ahead and bakes these light probes here. So it might take a while, and once that's done, everything's ready. These light probes are now baked. So that's really done for the light probes, but of course right now you can see that these objects here have still got this black area here. They are not yet being affected by the light probes at all. To fix that, you select the object, and if you move over to the object inspector, you can see that we've got this checkbox here which says use light probes. So I'm going to enable that checkbox, and straight away now you can see the illumination for this box has changed. It is now using those light probes. So I'm going to select the other boxes and enable use light probes for those, like so. And I'm also going to switch over here to the character object, and I'm going to find the skinned mesh renderer component, which I'm not sure which component it is that has that. We've got the face here, we've got the clothes, so I'm going to set it onto the clothes. I'm also going to set it onto the skin as well. And now we're using the light probes on the character object. So now if I press play on the toolbar and start to move around the level, we've now got much better illumination for the character and the boxes because it's using those light probes. It's looking much better. We don't have these sudden transitions to dark areas. So that's looking pretty good, and that's how we can get up and running with light probes. In this movie, what I want to do is to go ahead and add the looping music track to the level. Music really is a critical ingredient to any game, and right now if I press the play button on the toolbar, you can see that we have no music playing at all. There's no background music there, and that really takes away some of the magic of the game, and it really just takes the edge off the game. So I'm just going to stop the play button here, and we're going to be adding the looping music track. If I switch over to the audio folder here, you can see that we have two audio assets that we've imported earlier in the course. we have this magic crystal sound effect, and I can press play on the toolbar to preview that. That sound effect will be played when the level is completed. But we also have this little princess music track here, actually Little Prince, and I'm going to press the play button on the toolbar. So you kind of get an idea for how that is configured, and we've seen how this is configured here. We're using the compressed Ogg Vorbis format, and this is not a 3D sound, it's designed to be a music track that plays repeatedly. So now we're going to be adding that to the level, and doing this is really very easy indeed. All I have to do is just select an object in the level, one that we know is going to persist throughout the entire level. So in this case I know, for example, that we're never going to delete the root object. That's never going to be deleted. It will always be active throughout the entire level. So I'm going to select that object and I'm going to choose Component, Audio, and I'm going to add an audio source, not a listener, because a listener is usually attached to the camera and hears sounds, and audio sources, well, they play sounds, they make sounds. So I'm going to add an audio source component, and you can see that here in the object inspector. I'm just going to drag and drop the Little Prince sound effect into the audio clip slot here and release, and it says this is a 2D sound. That's absolutely fine, that's what we want. I want to make sure that play on await is enabled. That will make sure that this track plays as soon as the level begins, but I also want to enable the loop checkbox to make sure that the track loops. That is, when the track is played, it will then play again and again and again on an infinite loop. So I'm going to enable that as well, and that really is all we need to do. Now I'm going to press the play on the toolbar. It's going to play that track repeatedly. So let's give that a test. So I press play, and here you can hear the music track playing in the background, and really that's sounding pretty good. So really that's how we can get up and running with playing a music track in the game. In the preceding movie we added a looping music track to our game, and now I want to push the boundaries even further and add a prop which is going to be a fiery torch that we're going to be putting on the wall here. We're going to be doing that by using the shuriken particle system to create a fiery particle effect. Now before creating this effect we need to import the necessary particles package into the project, and the way we can do that is by choosing Assets from the menu, Import Package and Particles. Now we did import these at the beginning of the project, but if you don't have these imported you can do so now by using this option. So that's how you can go ahead and import the necessary particle texture assets that we will be using. But I'm going to be jumping over here to the meshes folder and the props folder, which is where I'm going to be starting really with the prop mesh that we're going to be using as the torch for the wall. So I'm going to drag and drop this prop mesh into the level and press F on the keyboard to frame this. Now right now it's outside the level, so let's just bring it in here. And you can see that it's completely purple because it can't find the appropriate texture, but we can easily fix that. We've seen how to do that before. We can jump over here to the materials folder, find the prop material, drag and drop that onto the object, and you can see it here in the level. Now right now it's very dark. This should effectively be a static object that we will light with light mapping, but just for now, so that we can see it better, I'm going to assume this is a dynamic object and enable light probes just for now so that we can see the illumination better on the object. So I'm just going to bring this up against the wall. Now what we will be doing once we've created one instance of these with our particle system is we'll duplicate this throughout the level to create other torches on the walls. So let's just position this on the wall, make sure that it's not penetrating too far, and we'll just move this up to somewhere roughly right. Let's just move it up here, maybe down just a little bit here. Let's bring it in a bit further in this way. So maybe something about there. There we have the fiery torch holder, but of course we need to create the flames using the particle system. So to get started with that, I'm going to choose Game Object here on the menu, choose Create Other, and I'm going to select here at the top we have Particle System. And straight away in the level you can see we've got these particles generated. Now because we're going to be adding this torch as a prefab object, I'm going to drag and drop the particle system here in the hierarchy panel to be a child of the torch mesh. So drag and drop that here, and so now the particle system is a child object. I'm going to position the center of the particle system to be roughly in the center of the torch area. Maybe something kind of like that. And right now we can see we have these particles being generated into the scene. Obviously if I deselect the object, we don't see the particle system, it pauses completely. I can only see the animated sort of preview of the particle system. When I select the particle system here in the hierarchy panel, you can see that preview here. I can start and stop that preview, also stop and simulate, and that looks pretty good. But right now we've got these big white sort of balls just floating off into the atmosphere here, and it looks absolutely nothing like fire. So what we need to do is we need to come over here to the object inspector and use the shuriken editor to start tweaking this particle system and end up with something that looks like fire. We'll get started at doing that next. So let's get started at creating the particle system. Now the first property in the editor here that I want to activate is this one here that says pre-warm. So I want to enable this, put a tick in the box. Now what does this do? Well, if we don't enable pre-warm, then whenever our level begins and we press simulate, it looks as though the particle system is just getting started. So that makes it look a bit unrealistic, because it means that every time the player enters the level, the flames start from nothing and then emerge in the level as though nothing had ever come before. So if we enable pre-warm, again the level will begin and it will look as though the torches have been burning for a long time. So pre-warm allows us to simulate that effect. So I want to activate pre-warm. Now the next problem we have is that really these particles are like kind of white fairy dust, and that looks nothing like fire. So we need to find an appropriate fire texture for that. Now we can find this by going to the standard assets folder, or moving over here and accessing the particles package that we imported and looking under the source folder and the textures group. So standard assets, particles, sources and textures, we have a range of different textures that we can use. Now you can see here that we've got fire 3, 4, flames that are really quite good for simulating fire. So let's see how these kind of work and interact. So I can drag and drop, for example, this fiery effect onto the particle system, and straight away you can see how that's looking. That's not really right, that's not what we want at all. So let's try and drag and drop this one onto the system, and again that's looking better. It's still not quite what we want. We have flame D, again let's see how that looks. Yeah, that's looking okay, but actually I'm going to settle on this texture here, which is flame E. So I'm going to drag and drop that onto the particle system, and we have this texture here. Now because of the motion and the way this kind of works, it really is still not looking very realistic at all, but we're going to be fixing this. Now the next thing I'm going to do first of all is to increase the screen real estate that I'm going to have here, so I can see the editor and the particle system kind of side by side and have more screen space. So I'm just going to minimize the hierarchy panel a bit. I'm going to minimize the project panel a bit more. Actually I can't minimize that further with a window based on the current size. So I'm going to sort of settle for something like this. And what we want to do now is to really tweak the behavior of this particle system so that in combination with this fiery graphic, we can actually start to make it look like flames. So I'm going to start it at that next. So now I'm going to tweak the particle system even further, and I'm going to pay particular attention first to the particle emitter, which is the part of the system that really is responsible for generating or spawning new particles. I'm going to be controlling the shape and the emission rate. So to do that, I move over here in the object inspector and scroll down, and you can see that we have these groups emission and shape. I'll start by tweaking the shape, so I'm going to click on shape, and when I do that a whole new group expands beneath. And you can see that for the shape of the emitter, by default it is selected to cone, and in the viewport you can see we have a gizmo here which draws out the gizmo, the emitter, which is a cone. You can see the shape represented here. Now I could of course go ahead and completely change this to a different shape. For example, I could move over to shape here, select cone and change it from cone to say box, and there we get a box emitter, which actually looks a bit better right now, but I'm going to be sticking with a cone. So I'm going to select on this shape parameter here and change it back to cone. So first I want to tweak the radius of the cone the base here, the base radius, to something really that's going to more closely approximate the torch mesh. So I'm going to move over here to the radius and just scroll that down maybe to something like 0.1 perhaps. Yeah, I think 0.1, that sort of more closely approximates this torch here. And again, for angle, this represents the angle of this outer radius here for the top of the emitter. So I'm going to bring this in as well. I'm going to reduce this perhaps quite considerably, maybe to something like 0.19, which really creates kind of like a cylinder almost. And that represents the general area where particles are going to be emitted. And that actually is looking better. Right now, the generation, the emission rate and things are still not quite right, but I think that this is a pretty good shape for the emitter. Obviously, I've actually decided on these values in advance, so I know what I'm going to be using. But in real life scenarios, you'll be sort of using trial and error, going back and forth and tweaking the values until you get something that looks right. So I'm going to switch to the emission group here, and really this is the emission rate, the number of particles that are generated into the system per second. So I'm going to be increasing this, so I'm just scroll this up to something else, to a much higher value. Actually, I'm going to be increasing this all the way up to 37. So let's select 37. And actually that's looking a lot better. We're getting a better fire effect here, but of course this fire is tearing way up here into the distance, and that's not right at all. So again, what I want to do is to tweak the particle lifetime and the particle speed. So I can scroll back up here to these main properties, and for the lifetime I'm going to specify a value of 1.5, and for the speed I'm going to specify a value of 0.78. And you can see when I specify those values now, we're getting something that's really looking much better. It's actually looking much more like fire. It's still not quite right, but we're going to be fixing that and tweaking it even further in the next video. Now I want to address one of the main problems that has been plaguing this particle system, and that prevents it from looking like real fire. Right now you can see we're generating particles at the bottom of the torch here, and then they just move upwards. But you'll notice that this fire always maintains the same width. And that isn't really how fire behaves in the real world. In the real world we have a kind of tapering effect. So the fire begins at its widest width around about near the bottom somewhere, but by the time the fire reaches the top it kind of tapers inwards in sort of a triangle or pyramid-like shape. So I want to bring that into effect now. I effectively want to change the size of the particle system over its lifetime. So I'm going to scroll down here in the Object Inspector, and you're going to see a group here which says Size over Lifetime. I'm going to put a check in that box to enable that and click here in this group to expand it. And you can see right here we've got this size field and this kind of linear graph here. Now I'm just going to click inside that graph to bring up the curves editor, which you can see in the preview panel here in the Object Inspector. And this kind of line represents the value or the size of the particle system. So on this horizontal axis from left to right, we have the lifetime of the particle, 0 being when the particle is born and 1 being when the particle dies. And the vertical axis here represents value. So the value of 1 represents the maximum or default size of the particle. And in fact, if I bring down this curve here by clicking and dragging, you can see in the viewport that we begin to get this particle system to thin out. And in fact, if I bring it right down to 0, we can't see it at all because it has no width or size. So I'm going to set the initial sort of size of the particle system to be maybe about there. But of course, as I say, over time we want this sort of width to taper off. So I'm going to select this last control point, this last handle here, just by clicking on it, and just drag it down here to the bottom to 0, like so. So you can see this curve drawing out the general size of the particle system over time. And you can see how that looks in the viewport, which is much better, but it's still not quite right. What I want to happen is to have a kind of curve going inwards here, but what we've got is a sort of S shape. So I'm going to grab this Bezier handle and just sort of pull it upwards here to get this kind of curve going outwards here. And now this is looking much better. You can see in this sort of shape how this tapers inwards, that we've got that reflected in the curve here. And just to prove that this curve really does control the shape of this particle system, we could in fact just drag this Bezier handle way up here to sort of ridiculous values, and you can see the kind of effect that has on the size of the particle system. But I'm just going to bring that back to some sort of sensible range here, to something like that, and that now is already looking much better. It's looking much more like fire, and it's beginning to sort of look believable. So the next thing I want to do is, as the fire rises higher, you can see here, we sort of taper out into transparency. And again, right at the bottom here, you can see sort of the particles being generated, being spawned into the system. And I sort of want to mitigate that effect just a little bit. So again, we can control this by changing the color of the particle system over time. So we have this field here which says color over lifetime. So I'm going to enable that checkbox and expand that group, and we get this color field here. I'm going to just click in there, and we get the gradient editor appear, where we can control the colors of the particle system over lifetime. So the left hand side is the beginning of the particle birth, and again the right hand side is particle death. I can, for example, select this color swatch, which represents the color to be multiplied to the particle system. Right now it's white. And again here, if I click on this one, you can see at 100%, again we've got white. So I'm going to set the starting color, this color here, from white. I'm going to change that to red. So I'm just going to click in that color picker, and maybe just choose red. And when I do that, you can see here in the preview here, the editor, that we've got this red effect sort of being factored into the particle system. So I'm going to leave that there. And again, this is going to taper out to not white, but to a kind of a yellow. So again, I'm going to select that sort of handle there and click in the color field. And I'm going to select a sort of a yellow, maybe something like this. And again, that's looking much better. So I also want to affect the transparency of this system, and we can do that using these top handles here. For example, if I select this handle, you can see the transparency. The alpha value is 255, meaning fully opaque. And the same for the end handle here, which is also 255. I'm just going to change that to completely transparent and set that alpha there to 0, so that we sort of fade out into transparency here. And again, I want to soften the introduction of these particles, so I'm going to set this also to an alpha value of 0, and I'm going to introduce another swatch here, and I'm just going to increase that to 255 to try and mitigate the generation effect that we get going on with the particle system. So I'm kind of happy with these values here. I think that's looking pretty good. I also want to affect the rotation of the particles over their lifetime. So I'm going to click on the rotation over lifetime and enable that. I'm going to set the angular velocity to about 106 to kind of add a sort of swirl to it. And I think that now is looking much better. I might off screen go ahead and just tweak it a little bit, maybe changing the particle system up here just a little bit like that. But I think overall that's looking pretty good. Let's just grab that wall torch and just move it down a little bit into the level and just take a sort of brief look over how this is looking. I think that's looking pretty good. Maybe just bring this just out a little bit further. Grab that particle system, maybe just bring it forwards a little bit, like so. Yeah, I think that's looking pretty good. And we've got a nice fire effect going here, and in the next video I'm going to be sort of creating a prefab from this and duplicating it throughout the level. So now we've created the flame torch particle system, and I think it's looking pretty good. So I'm ready to go ahead and create a prefab from this object. By creating a prefab, it means that I can reuse it anywhere else in the level really easily. Plus, I even get to use it in any other levels that I might want to create. So before going ahead and creating the prefab, make sure over here in the hierarchy panel that the particle system has been added as a child object of the wall torch. It's important when creating prefabs that there is one root object and all the rest are children of it. And I'm going to move over here now to the project panel and select the prefabs folder, because I'm going to organize all my prefabs in this folder. I'm going to right click and from the menu choose create and then select prefab. I'm going to name this prefab torch prefab and press enter on the keyboard. And I'm going to drag and drop the torch object, careful here, not the particle system but the torch object, the root object. I'm going to drag and drop that into the prefab here, and straight away it's created a prefab. And this original wall torch object has been added as an instantiation of that prefab. So here in the project panel we have that prefab, and then we have this little right pointing arrow, and I can click that to expand the group, and you can see right here we've got a particle system which is included in the prefab. So now I can just go ahead and add more instances of this prefab to the level. So I can just drag and drop this into the level and just move this up and bring this in here like so. You can see we've got our prefab object. I'm just going to align this here to roughly about the center of the wall. Let's just zoom in and just bring that up here like so. Again, I'm going to duplicate this by pressing Ctrl D on the keyboard. And again, I'm going to just rotate this. Actually, I'm just going to rotate this 180 degrees on the y-axis using the transform component. Let's just bring that here like so against the wall, just penetrating just a little bit, and then just press Ctrl D again. And I'm going to bring the torch over to the other side, around about there. Doesn't have to be exact, we can always come in and tweak it later. And again, if I press play on the toolbar, if I switch back to the scene tab, you can see here all of our particle systems are running very nicely, and that's looking pretty good. Of course, the great thing about having these as prefabs is that if we later decide to make any change, for example, let's say I want to move back here to my prefab, select the particle system, and I want to make a change to the particle system, I can make the change here in the prefab, and those changes will be propagated to all the other particle systems. For example, if I wanted to, for example, change the shape of the emitter, and I wanted to change it from a cone to, say, a sphere, like so, I can now press play on the toolbar, switch to the scene tab, and you'll see all of a sudden the emitters for all of the particle systems have changed. So I'm going to stop that, change that back to a cone, and press play, and you'll see that everything again is back to normal. Of course, if for example I wanted to change just these three particle systems, but I didn't want to affect this one, you can do that by breaking the connection to the prefab. So for example, I can select this object here. If I no longer want this connected to this prefab, I can move up here to the menu, choose Game Object, and then choose Break Prefab Instance, which will break the connection with the prefab. So that's how we can work further with prefabs. We've now reached a stage in development where we can start thinking about post-production. And this refers to all the effects that we can apply directly to our camera and our render that we have here in the viewport. All the effects that we can apply to that camera in order to improve the appearance of our game. We can add things like bloom and vignetting, and these are the kinds of things that I want to talk about here. Now, to add these effects in Unity, you will need to import the Image Effects asset package if you have not imported it already. We imported it at the beginning of this course, but if you don't have it imported, you can import it easily by moving up here to the File menu, choosing Assets, Import Package, and selecting Image Effects. You will see in brackets that it says Pro Only, which means that if you're using the free version of Unity, you won't unfortunately be able to follow along with this section. It is for Pro Only users. So you can go ahead and import those image effects if you don't have them already. Now, the first thing I want to do is we're going to be applying these effects directly to the camera. I've switched over to the Game tab and selected the camera so that we can see a live update of the effects as we apply them here. So the first effect that I want to apply is the bloom effect, and what that does is it effectively intensifies the highlights in the scene and it blurs them both in one operation. Now what this does is it really gives us a kind of dreamy fantasy effect. We often find bloom in fantasy RPGs, and because our game has a kind of fantasy setting, bloom is appropriate here, but it's important not to overdo bloom because it can really distort your renderings. So let's take a look now. I'm going to select the camera object here in the hierarchy panel. I'm going to move up here to the component menu item, choose Image Effects, and I'm going to be choosing bloom and glow, and you will see here that there are a variety of bloom options. I'm going to be selecting bloom optimize from the menu and select that, and it's added as a component to the camera. You can see the component is called fast bloom, and if I toggle on and off this component, you can see the effect it has directly to our camera in the viewport, and really it's quite a dramatic effect. So what I want to do first of all is change the threshold value. Now, the lower this value, the more pixels in this image the effect applies to. So I'm just going to increase it just a little bit, just to reduce its effect. And again, the intensity refers to how strong the pixels are affected. So again, we can really apply some quite extreme values there, but I'm just going to reduce that to maybe something like, kind of like this, perhaps around about here. And again, the blur size, the amount of blurring to apply, just going to increase that perhaps a little bit and toggle this on and off to see what we've got. I think perhaps that I'm going to just reduce the intensity just a little bit here, like so. Again, toggle on and off, and I think that's looking much better here. It's really a good idea to try to start with subtle effects first, and if you think they're not good enough, then to intensify from there. So we've gone ahead and added a bloom effect here. The next effect that I want to add is vignetting, which adds really a dark blurred border around our image and a kind of blurring around the edge, so that it kind of sharpens our focus to the center of the image here where the character is going to be pushing boxes. So to add vignetting, I'm going to choose Component Image Effects, select Camera, and at the bottom here you can see Vignette and Chromatic Aberration. So I'm going to select this here and scroll down in the Object Inspector. Of course, when we added that component, you have to make sure that the camera object is selected. And you can see we have options here for vignetting and chromatic aberration. Now, I can just toggle this on and off, and you don't see much of an effect yet. The chromatic aberration option is not one that I'm going to tweak here. Of course, we could just increase this and really start to dramatically change how our renders look. Chromatic aberration is not appropriate for this kind of game. It could be useful if you're creating some kind of cyberpunk futuristic thing, but that's not the case here. So I'm going to press Ctrl Z to undo those settings and focus only on vignetting here. So I'm just going to increase the vignetting value and just show you what it does. You'll see that as I start to increase this, again, we're starting to home in on this sort of visible section in the center, adding a dark border around the edges. So I don't want anything quite like this dramatic effect here. So I'm just going to reduce this maybe to something like that, just to add a kind of subtle darkness around the edges here. And again, I'm going to increase the blurred corners just a little bit. And as I increase the blurred corners, the strength of the blurred corners, you get this new parameter unfold, which is the blurred distance, which refers to the size of the blurring area. I'm going to set it to something like that, and if I toggle it on and off, you can see that actually there's been quite a big difference. In fact, I'm just going to reduce the vignetting effect just a little bit more, toggle on and off, and maybe just reduce that a little bit further, and again toggle on and off. And I think that's probably pretty appropriate here. I might just reduce the blurred distance just a bit more here, and again just reduce the blur corners just a little bit, toggle on and off, and I think that's about right. That's looking pretty good. There's just this subtle darkening around the edge, and it just sharpens our focus to the center of the image here, which is what we want. So I'm just going to press play on the toolbar, and I think that with our image effects this is now looking quite good. Yeah, I like how this is looking. The effects really make these sort of colors pop and stand out. That's looking excellent. So let's move on. Now, one common task that you may want to do when testing your games is that you want to test to see how it looks on different resolutions and aspect ratios. And there's a really easy way that you can do that if you come over here to the Game tab. You will see that by default the Game tab here is listed as free aspect, which means that if I press spacebar to maximize this view or I minimize it, you can see that the view always expands to fill whatever size the screen might be, so that when I play the game, it will play it at this screen size and resolution. And that might be fine in many cases when you're testing the game and you don't really care about the resolution or the aspect ratio. But sometimes you might be targeting a particular device, particularly on mobile platforms, where you need to develop for a specific resolution or a specific aspect ratio. And so you can click on this drop down here to begin to tweak and change these values. For example, If I click on the free aspect here, we get these settings here. For example, if I want to test on a wide screen, a 16:9 aspect ratio, I can select that. Immediately you'll notice that some of the view here is chopped off. We get these grey margins at the edges here, and in fact if I come back out of this view again, we still get these green margins. What this is doing is it's stretching my view here to fit the screen, but it's preserving the 16:9 aspect ratio. So now whenever I play my game, it will always play at the 16:9 aspect ratio. You're not only restricted, of course, to testing specific aspect ratios, you can also test specific resolutions. For example, I can move over here and choose standalone 1024 by 768, which is not just an aspect ratio, but it's a fixed resolution. So I'm going to select that value here. And again, more of these values here were chopped off at the edges to preserve 1024 by 768. I can exit this panel. Again here, you'll notice it's still chopped off. And if I press play on the toolbar, we're now playing at this old school resolution of 1024 by 768, and things are looking good, but it's really just this restricted square resolution. Now, of course, you're not restricted to just 1024 by 768. You can add your own custom resolutions as well. To do that, you click on this drop down, and at the bottom you click on the plus icon here, and you can specify a fixed resolution. So let's say I want to test at 800 by 600. This is a really old resolution. It's been around for a long time. So I'm going to choose 800 by 600, choose OK, and this is now listed as an option in the drop down. So I'm going to select 800 by 600, maximize this view, and now we're testing at the resolution of 800 by 600, and things are looking pretty good. So we can test it at any resolution we like. Of course, when I click on this drop down list, if you no longer want this resolution, you can just right click on it and choose delete from the menu, and that goes away. And I can just set this back to, for example, free aspect, and it now fits the screen as it did before. So that's a really quick and easy way at how you can test your game at different resolutions and aspect ratios. It's important to mention, however, that these settings that we apply here for testing at these different resolutions, they don't actually affect the final resolution that your game runs at. These are here only for testing purposes. Now, there'll come a point in development when you're ready to build and deploy to your platform of choice. At that point, you'll want to fill in the product details for your game, such as the company name and the game name, and you'll also want to fix in the final target resolution and aspect ratio that your game should support, and I want to show you quickly how you can do that here. So first of all, you will select File from the menu here and choose Build Settings, or press Ctrl-Shift-B on the keyboard. And when I do that, it displays the Build Settings dialog here. From this dialog, just click the Player Settings button, and in the Object Inspector you can see the main settings for your game. Now, I've typed in the name 3D Motive, and I've also typed in the product name Box Pusher with an exclamation mark at the end. So then what we have here are the main settings for our game. Notice that I'm on this tab here, which is listed as PC, Mac and Linux standalone, and these refer to the build settings for those platforms only. If you're building to something like the iOS or Android or some other platform, then you will have to switch to those particular tabs and tweak those build settings as appropriate. But right here I'm just covering the desktop platforms. So for resolution, there is a tick here in default is full screen, which says that your game will run by default in full screen mode. So you want to disable that if you don't want it to run in full screen mode. And in fact, this might be kind of like a 3D casual game that people might play alongside doing other activities. So you might actually want to disable full screen for this kind of game. There is default is native resolution, and that means the game will run at the native resolution unless you specify a different resolution. So for example, you could disable this checkbox and provide a particular resolution that is to apply to your game by default. So right here the default is 1024 by 768. If I wanted the game to run at a different resolution, I could of course specify different width and height values. I'm just going to leave default is native resolution here. There's this setting here, run in background. You can disable this. If you disable run in background, what will happen is when you minimize the game, then it will continue to run in the background. Right now by default it's disabled, which means that when you minimize the game, it will pause instead. So it will stop running, it will just freeze, and when you resume or when you maximize the window again, the game will begin running. So we also have this display resolution dialog, which by default is enabled, and typically you may want to disable this for your final builds. If this is enabled, then when your game runs, at the very beginning it will display a Unity branded configuration dialog that will allow the user to choose the resolution to run the game at. You may wish to provide resolution selection in your own in-game options screens, and if you do that, then you want to disable this dialog. So we have that here. We also have supported aspect ratios. If you don't want to fix the resolution of your game and you just want to support a range of aspect ratios, you can toggle which ones that you wish to support here. So these are the basic build options that you have for your game, and I suggest making sure that you fill all these in before creating your final builds. So in creating our game so far, we've come a long way. We've managed to create 2 levels. We've created box pushing functionality, a character that can push boxes that can arrive at their destinations, and we even have a game manager that can detect for a win condition. We've got flaming torches. We've also got the ability to illuminate moving objects in real time using light probes, and we've also got image effects going on, image effects like bloom and vignetting. So we've really achieved quite a lot with our box pushing game, but I still can't help feeling that we can achieve even more. There's still something very important that I think is missing, and that's the ability to save and load our game. Right now, even if I get to the 2nd level, if I exit the game and load it back again, we can't resume back from where we left off. So we're going to want to add some kind of load and save functionality, and that's going to be the focus for the next and the final part of this course. But in this section we've achieved a whole lot, and I hope you found it really useful. My name's Adam Thorne, and this has been 3D Motive. Next up we're going to consider load and saving, so stay tuned.